All right, so this is the notes for the second lesson in this chapter on identities. And I start off with, some identities. Now, all of these we kind of explore in a bit of detail in class. So right now, all I want to say is, you got to memorize these. But for the time being, the starting point to memorizing something is to write them down. And this ends all the things we have to memorize. There's a fair amount here. Although I will say the most important ones, I would say, are these two and these two. Okay, but that's it. We do want to know all of them, and we look at this in more detail in the group problems. But these are all the remaining identities. All right, without me just reading through all those, let's look at this. Okay, a pretty abstract problem that, as usual, won't require a lot of steps. So I say let sine of theta equal 3 over 4, where theta is between pi over 2 and pi. Determine the exact value of sine 2 theta. So first, what's happening here? Well, I'm telling you the output for sine, but I'm not actually asking for the angle. Notice in the end, I'm asking for the sine of 2 times the angle. I'm not trying to find theta. So don't think we actually need to ever figure out what theta is. However, right here, this restriction right here tells me that theta is between pi over 2 and pi. Well, pi over 2 is 90 degrees. Pi is 180 degrees. So this is describing a quadrant. This is one way of saying that my angle is somewhere in quadrant 2. Right, so everything you see right there is the same as saying that my angle is somewhere in quadrant 2. With that said, I want to find the sine of 2 theta. So hopefully, the sine of 2 theta sounds kind of familiar. That relates back to one of our identities. If I look up here, it's what we call a double angle identity for sine. And right here, the sine of 2x is always the same as 2 times the sine x times cos x. The only difference between this and what I have down below, instead of an x, I have a theta. So I can take this sine of 2 theta and rewrite it as 2 times the sine of theta times the cos of theta. OK, great. How does it do me any good? Well, if I look right here, sine of theta, I know what the sine of theta equals. I know the sine of theta is 3/4. So I don't actually have to know what the angle is. I know the sine of 2 theta is going to be the same as 2 times 3/4. What I don't know yet is the cosine of theta. Again, I don't actually have to know the angle. I just have to know the cos of the angle. So how can we figure out that part? Well, remember that cosine, I'll make a little note here. Cosine, as an angle in standard position, is defined as the x-coordinate of some point on the terminal arm divided by r. And remember as well that x squared plus y squared always equals r squared. Well, if I look back at what I told you up here, when I said sine was 3/4, that means I know my r is 4 and my y is 3. And so I can figure out cosine without actually, I can figure out the cosine of theta without actually ever figuring out theta, which, if that sounds strange, we did that a lot in the mid part of chapter 4. We'd find the exact value of the cosine of 5 pi over 3. We never actually found the angle, but we found the cosine of it, or the sine or the tangent or whatnot. And so I can now piece this all together because I know that r equals 4 and y equals 3. And so I can now take these, replace them here. And so I now know that x squared plus 3 squared must equal 4 squared, which means x squared must equal 7, which means x must equal plus or minus the square root of 7. Now, in this case, x is a coordinate. X can be negative. It can be positive. And so I have two possibilities here. So what do I put right here? Remember, cosine is x over r. So I know r is 4, but what is x? Is it positive root 7, or is it negative root 7, or is it both? Well, this is where we need to go back to this step right here. It's in quadrant 2. In quadrant 2, which is right here, my x values are always going to be negative. If I was in a different quadrant, if I was in quadrant 1 or quadrant 4, then my x values would be positive. And so I know, because I'm in quadrant 2, that I need to look at just minus root 7. That's because we're in quadrant 2. And now I know that the cosine of theta, even though I don't know the angle, I know the cosine of theta must be minus root 7 over 4. And now it's just a matter of arithmetic. Okay, and so that's it. There's a few ways of doing this, but I get 6 minus 6 root 7 in the numerator over 16. I can reduce 6 over 16 down to, oh look, my voice is cracked, down to 3 over 8. So negative 3 root 7 over 8. And as I always say, I don't really care about this number. I care about how we got to it. And again, for this question, we never actually needed to find the angle to find the sine of 2 times the angle. But really, this is really just forcing us to kind of use that identity and connect it back to chapter 4. Hence, it's probably kind of difficult. All right, all I've left is a final problem. Again, I don't need a lot of notes on these things. Really, we're just introducing these last identities. So what I want to do here is simplify. I have 2 questions, I believe, here. Oh, 3 questions I have. Simplify each, writing it as a single trigonometric equation. All right, and somehow using an identity. So I have cos squared of pi over 3 minus sine squared of pi over 3. Well, that's not a highlighter. So what I want to do first is, OK, this is in the same form as one of our identities. Which one? If I look back here, cos squared something minus sine squared, that same something. That is what I see right here. So I can use my double angle identity for cosine to rewrite this. And so I'm going to make a little note here. This is in the same form as cos of 2x equals cos squared x minus sine squared x, which remember I said was one of the more important of the identities I gave us there. And in essence, we have to realize instead of x, I have pi over 3. And I want to write it from this form into this form. So let's do it. So I can rewrite the cosine of pi over 3, sorry, cosine squared of pi over 3 minus sine squared of pi over 3 as just the cosine of 2 times pi over 3. Again, what I did from here to here relates back to going from here to here. Everywhere there was an x, I have a pi over 3. Once I've done that, I'm essentially done the question. I don't need these brackets anymore, though, so I might as well write this as the cosine of 2 pi over 3. And notice that there is the same as this, but I think it's safe to say that is simpler. The cosine of 2 pi over 3 is a single function. Nothing's being squared, but it's equivalent. Okay, and all these questions are like that. We have to somehow connect it back to one of the identities that we've probably seen today and write it into a different form. Okay, let's look at this one. 2 minus 4 sine squared times sine squared of 8x. Okay, so what is this the same form as? This is similar to a different variation of the double angle identities for cosine. It's similar to this. The cos of 2x equals 1 minus 2 sine squared x. The main difference between what I have here and the identity that I've just written down is that the equation I gave you, or the expression I should say that I gave you, is it's 2 minus 4 instead of 1 minus 2. It's doubled. My coefficients are doubled, which I can take care of. If I take my original expression and take out a factor of 2, I get this. Now, that 8x doesn't change when I take out a factor of 2. Because remember, this part here, sine squared of 8x, means the sine of 8x, right? 8 times x is going inside the sine function, and all that's being squared. There's a lot of stuff going on. And then all that was times by 4. So when I divide by 2, this reduces down, but the 8x is inside the sine function and all being squared. There's a lot of stuff going on here. OK, now what I see right inside the brackets, I can see that 8x is equivalent to my x I have highlighted up there in yellow. So I want to take this, and I want to write it like this as a single function. So all of this I can rewrite now as just a cosine of 2 times x. Well, in this case, not x, 8x. And then all of that is being multiplied by 2. And so at this point, I get 2 times the cosine of 16x. And that there is, again, equivalent to what I started with. But it's definitely simpler. In this case, I had to use one of my double angle identities for cosine, but first I had to take out a factor in order to get it more in the form that we needed. All right, one last one. Now this is a single term, but there's two functions going on here. So again, we have to think, what is this most similar to of all the identities we've seen? This is most similar to the double angle identity for sine. The sine of 2x is always the same as 2 times the sine of x times the cosine of x. So it's in that form. All right. So here I have an x and x. Here I have 6x and 6x. And as well, I have a coefficient of 8 in the front. I need to get it to a 2 in order to use this. So what I want to do first is I want to take my expression and I want to factor out just 4 from it. And by doing that, that 2 you see up there, I now have the same form. And now it really is in the exact same form as what I wrote in the identity. And so I want to take all of this now and write it like this. So how can I write all this? Well, inside the brackets, instead of 2 times the sine of 6x times the cos of 6x, it's going to be just the sine of 2 times what I've highlighted, 2 times 6x. And all that's times 4. So I have 4 times the sine of, not 8x, 12x. And then again, I'm done. None of this is easy. And notice, if you have these, once you have these identities memorized, being able to see how this looks in the same form as this is not a big leap at all. If you have nothing memorized and everything I did seems completely arbitrary, or it just seems like I just pulled something out of nowhere. And that's why we need to have these memorized. By the time you have a test on this unit, I will give you a sheet with all the identities. But if you don't have them memorized before then, it won't really do you much good, because you won't know where to look for anything. You won't look at something like this and think to yourself, hey, I've seen that. That's similar to one of my identities. And so your homework quiz for this chapter will not be allowed. You will not be given an identity sheet. I need us to memorize these things, but by the time you have a test, you will be given a sheet with all the identities. But trust me, and I've said this from the start, if we memorize these key things, it makes everything easier. But that's it. I think that's it. Yeah, that's it. So you don't have to hear me talk.